Okay, question 25 of the Blacktown Boys 2020 trial. A biologist assumes that there is a linear relationship between the amount of fertilizer supplied to tomato plants and the subsequent yield of tomatoes obtained. 8 tomato plants of the same variety were selected at random and treated weekly with a solution in which X grams of fertilizer was dissolved in a fixed quantity of water. The yield, Y kilograms of tomatoes, was recorded. Use the scatter plot to describe the association between yield and fertilizer in terms of strength and direction. So we can see here that the scores are quite close to the line of best fit. We can even have a look at this r squared here. If we to find the square root of that to find Pearson's correlation coefficient r, we can just say that r is equal to the square root of 0.9453, which is 0.9722. So which is very close to 1. So we can see here that this is a strong, positive, linear association. Okay, we've got our strength, strong. You could say very strong if you want. And it's positive. Question B. Determine the equation of the line of the least squares regression line for this data. Round your values to 2 sig figs. So in order for us to determine the equation of this line, we know it needs to be y equals mx plus b. So what we're going to do is we're going to have a look at the data again in a table, and we're going to input that into our calculator. Now this is bivariate data, so we need to put it into stat mode. And because it's bivariate, there are 2 variables we need to press 2. We need the a and we need the b, and once we get a and b, that's pretty much our equation of the equation of the line of best fit. So I hit 2. I'm going to enter all my x values. Now it says I've entered 8. Let me just double check there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Right, down arrow, and enter my y values. 3.9, 4, etc. Good. Press the AC button. To get all our S's, we need to press Shift 1. And this is regression, so I'm going to hit number 5. And we've got A and B there. So, alright. According to our calculator, it's A plus BX. So let's see what A is equal to. 2.592. Now this is the two significant figures, so I'm going to say 2.6. 2.6 plus B is 1.4, and then I need my X. Okay, so I'm just using this. Question C. A plant with 2.2 grams of fertilizer was not recorded by accident. Calculate the predicted yield for this plant using your answer in part B. So here's our answer. We know that X is the amount of fertilizer, Y is the yield. Let's just double check that according to the question. Yes, Y is the yield. X grams of fertilizer. So just to make sure that we substitute the values in correctly. So the yield is going to be 2.6 plus 1.4 times the fertilizer used, 2.2. 5.68. And this will be kilograms because according to the question, the yield was in kilograms. Okay, question D. Explain why you should not extrapolate from this data to find the yield for high rates of fertilizer usage. So the reason why you shouldn't extrapolate from this data is because when we have a look at the original question, let me just highlight it for you. It says the solution in which X grams of fertilizer was dissolved in a fixed quantity of water. So if the ratio of fertilizer to water is too high, then that could actually be harmful towards the plant. So I'm just going to write here that high volumes or a high ratio of fertilizer to water may cause damage to the tomato plant. Okay, so we can't assume that the more fertilizer there will be, the higher the yield. I'll just write it in. Therefore, can't assume that the more fertilizer used, will result in a larger yield. So we should not extrapolate from this data.